sharp, the future's calling. Maths and mind colliding. Daily dose of power. AI's here. Siya. Kubeka, let's learn the new way. Siyahamba phezulu. Daily dose of power. AI's here. Siya. Kubeka, let's learn the new way. Siyahamba phezulu.
Hi guys, welcome to another lesson of the Daily Dose of Mathematics. In our lesson today, we are doing 3.1.1 of the June 2026 Limpopo question paper. I have Sia and then I also have Dimpo who are going to be assisting us in the question. Sia, what is our question?
The distance an object travels from a starting point at a particular time is recorded in the table below.
Okay, Dimpo, can you take us through our table? What is our table? What does it say?
Time in seconds is 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds.
And so on, okay. And then what is our pattern from there? We have 1, which goes with what?
4.
Okay, so we have 4, and then after that, 2 goes with what?
2 goes with 10.
Goes with 10. So that's our second pattern. So basically, the time represents our n, the position. So what is going to be our third term?
It's 18.
It's 18. So it creates a certain pattern.
Yeah.
So we're supposed to determine the next 3 terms. Basically, we're supposed to determine term number 4 after 4 seconds.
5 and 6.
Yeah. So after 4, 5, and 6. So that's what we're supposed to do. That's what we are tasked with. Now, before we can do that, they didn't specify what kind of a pattern it is. Yeah? So we're supposed to go and investigate and find out what kind of a pattern it is. So we know that the patterns that we usually do, it's linear, it's geometric, and then it's quadratic. So we're going to check between the 3 of them here and check if we can find out what it is. Let's start by checking if it's linear. That's always where we start because it's the simplest. Now, how do you check if it's linear? You're supposed to say term number 2 minus term number 1 and get an answer. What is our term number 2 in this case? The second term.
6.
Second term. We have the first term, we have the second term. What is our second term?
10 is 10.
10. Okay. What is our first term?
First term is 4.
The first term?
4.
First term is 4. Ne?
Yeah.
So we're going to have 10 minus 4. If we
Which
say
is
10
6.
minus 4, yeah, it gives us the first term of the first difference is going to be 6. Ne? And then we write that. Now, after that, we're going to say term number 3 minus term number 2.
It's 8.
It's 8. Now, we can clearly see that 6 and 8, they are not equal. So it means that it's not a linear pattern. So we can write off linear. Ne? So we're going to check the second one. Let's check if it can be geometric. How do we check geometric? Geometric, it's a ratio. We're going to check term number 2 divided by term number 1. Now we're checking a ratio. If the ratios can be equal, then we're going to conclude that it's geometric. So we're going to tell them term number 2. What is our term number 2?
Term number 2.
It's 10. Okay. All over our term number 1. It's 4. Ne? And then we're going to check this in our calculator. What do we get as an answer? If you say 10 divided by 4, you're going to get 2,5. Yeah, you can check it.
10 divided by 4 equals to
10,5.
2,5.
Okay, it's 2,5. Okay. Now, this is the first ratio. Let's check the other ratio. We're going to say term number 3, which is 18. You can check it there on the calculator now. Say 18 divided by 10. And then if we say 18 divided by 10, it's going to give us 1,8. Just double check. Yeah, divide by 10.
Divide by 10. Yeah, it's 1,8.
Now you can see 2,5 and 1,8 are not equal.
Yeah.
So it makes it not to be linear. It also makes it not to be what? To be geometric. Because the ratios are not equal and the difference are not equal. Now, guys, for us to check if it's a quadratic, we're supposed to have 4 terms. But now, we're going to assume that it is quadratic because looking at 3.1.2, we are told that D. Now, if you check on the next video that we're going to be doing, we are told in 3.2 that D is equaling to M to the power of T squared plus N T, which makes it to be quadratic. So that's what gives us a hint to say this thing here is going to be a quadratic. So starting from now onwards, we're going to approach this question as if it's quadratic. So if we assume that it's quadratic, let's go and determine the next terms now. We're going to say that we have 4. Ne?
Yeah.
And then we have 10
And then 18.
And then we have 18. Né? Now let's get the first term of the first difference. We said it's 6. Né?
Mm.
And then we're also going to say we have the second term of the first difference. It's
Which is
18. Yeah, it's 8. Okay. Now from the onwards, if we go down now, we're going to go down, starting from the bottom. We say 8 minus 6.
2.
It's 2. Yeah, so this is the second difference. Né? So we assume that it's quadratic, meaning that the second difference is going to be constant. So for us to get the other terms now, we're going to get the third term of the first difference. We're going to tell them that we are going to add 2 to get the next one. Né? So if we say 8 plus 2,
8 plus 2 is 10.
so we're going to get 10. Né?
Yeah.
Now from there onwards, we can then tell them that we have 18 plus the 10 that we just got now, which is going to give us the first term that they wanted. Remember, they said after 4 seconds, yeah. Yeah, then after 4 seconds, our distance is going to be 18 plus 10. What is 18 plus 10?
28.
Then it's going to be 28 sharp. Okay, next, we're going to tell them that moving from the second difference again, the second difference from the bottom is 2. No?
Yeah.
So we're going to tell them that we have 10 plus 2.
10 plus 2 is 12.
So we're going to tell them that we have 12. No? Okay, now from here we can say that we have 28 plus 12, Dimple. What is 28 plus 12?
28 plus 12 is 40.
It's 40. Okay, we're going to write 40. So this is after 5 seconds. The distance is going to be equaling to 40.
Yes.
So we write that. Okay. Now we're moving on again. Go back to our bottom again. Our bottom is 2. Remember, second difference is constant. Yeah?
Yes.
Then we say 12 plus 2. What
12
is
plus 2 is 14.
It's 14. Okay. Then we're going to say we have 40 plus the 14 that we just got.
It's 54.
It's 54. Okay. So these are the first 3 terms the next 3 terms that they spoke about. You know? Now, guys, we're going to go to our senior marker and then we're going to paste our solution. While we're doing that, we have a quadratic song. Every time when you think of quadratic, this is the song for you. If you want the song, you can request it on the comments. We have it. So yeah, let's go to the song.
Let's get it. We're looking for the pattern. First difference, changing. Second difference, constant. Let's build it from the floor up. Ensemble. Listen up, class. Let's look at the board. We got a new pattern that can't be ignored. The first difference changes. Hey, Bo, it isn't the same. If the second diff is constant and true, then the quadratic pattern is waiting for you. Stop from the bottom and work to the top. Pesulu. 3 little formulas, please don't stop. 3 little formulas, please don't stop. 2 equals second diff. All back at 3AB is the first of the first.
Okay, let's listen to our senior marker, guys, on how did you approach the question. Remember, we use the senior marker since we're preparing for our examinations so that we are assisted. Yeah, what does the senior marker say?
Final grade, 3/3. Final answer, 28, 40, 54. CAPS marking audit. 1. Marking breakdown. Step. Working shown. Mark allocation. Justification. Second difference. Extended V, diagram showing constant 2. Checkmark A. Accurate identification of the constant second difference across all terms. Next terms generation. Full expansion mapping to 28, 40, 54, checkmark M, checkmark CA. Standard processing applied. Initial logic and arithmetic extensions are completely validated. 2. Corrective feedback. Your work for 3.1.1 is perfectly accurate. Expanding the V diagram all the way across the newly calculated terms was a brilliant self-correction. It visually proves that your second difference holds constant, guaranteeing that the terms 28, 40, and 54 are mathematically sound for this quadratic model. 3. CAPS and formal notation compliance. Terminology. you successfully demonstrated the defining property of a quadratic sequence, a constant second difference. Notation. I must reiterate the sequence notation rule. 4, 10, 18, 28, 40, 54 uses commas. In the CAPS curriculum, you must use semicolons. 4, 10, 18, 28, 40, 54. Additionally, the geometric ratio test, T_2, T_1 equals 2, 5, is still floating on the right side of your page. In a final exam, draw a single, neat line through any abandoned working so the examiner knows exactly what to mark and what to ignore. 4. Coach's summary. What you did well. Fully extending the first and second difference brackets across the entire sequence is the gold standard for verifying quadratic sequences. It leaves absolutely no room for arithmetic slip-ups. Area for improvement. When you realize a previous method, like the geometric test, is incorrect or unnecessary for the current question, strike it out immediately. Clean paper management prevents both you and the examiner from getting distracted by dead-end logic.
See a bonga for pulling through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your thoughts. Your comment counts, tell us what you need. Your comment counts, tell us what you need. Find us on TikTok and Facebook. The daily dose of mathematics is the handle. Hit our WhatsApp for the daily prompts. Get more info on 0664 682 9994. 064 682 9994. Hamba kahle until the